Hello guys and girls, and welcome back to my video. So today we're going to be talking about autocompleter. So you probably are asking, like, what is in the world is this? What is Dr. Schuller giving us? So, am I recording? Yes, I'm recording. So let's begin. You guys already know what an AVL tree is. It's just a a balanced tree overall. So let's go ahead and look at the code. So what does Dr. Schuller give us? So if you look at the bottom portion, so all of this above is just code that you have to fill out. He gives you a height, so report height of the AVL tree runs in constant. And he gives us an entry, which is the string and the frequency. We also have a node where we have weights and two different nodes. Alright, so we have our height. We have our helper methods, which are height. Optional helper methods, you probably want them. These are quite important, by the way. And then, let's see, completion recursion. Does he give you this? Oh no, these are helper functions you need to make. So there's a recursive function that a helper function, insert, rebalancing. So you guys know what that is. Right rotation and left rotation. If you want to do right rotation, or whatever he explains during class. Let's see. So he has these images of rotations. So AVL rotations. So you have your single rotations that you have, and right-left rotation and left-right rotation, which are easily implementations. Alright, so we have the general idea of what's inside our code, so let's read off the comments. So create a new autocompleter with an empty directory. So that one's pretty simple and self-explanatory, so let's get here. So how would you write this is... It's just a root. So you just have a okay. I think this is a little bit too light. What's in this one? All right. So you erase what link, error option. Let me write this again. So we have this. Oh my god, I can't spell. Oh god, I can't spell. Alright, you know what? I'm just gonna do this. So, we have... We're starting off with the first thing, which is our constructor. And what our constructor basically just is saying is just create an empty dictionary. So it's just that. This is going to be a node. That's just going to be a node that you're going to be using. And on this node, we're just going to set it to just null pointer. Yeah, sorry if my handwriting's a little bit off. I'm using a drawing tablet and it's, it's there. So yeah, your constructor, fairly simple things that you need to do. Just create it as a, let's see here. Just create an empty one. Let's see. Would this change the mouth position? Yes, there you go. That's the position I want. Alright. So our second one is insert. So what are we going to insert it into our thing? Well, we're given words. So we're going to create an entry. Oh god, I am messing up here. Entry. And from entry, it has two things. A string and frequency. Frequency. I'm not gonna rewrite that. So let's see. Alright, I'm trying to fix some of these settings that I have. So we have our string and frequency. That's what it's going to be containing. And what we're going to do is we're going to be using our helper function. So our helper function is going to be mostly in charge of checking. First, I recommend you check your head or your root. Check if it's a null pointer. No, I'm not. Check if it's a null pointer, your root. So this is your root. And then if, for example, it's null, you just make that into your entry, your first entry. So just assign it to create a node with the information of entry. If not, check your children's node, because you know there's a binary tree as a right and left. So what you do here is just check the string, because it's in alphabetical order, correct? So S is string, correct? Let's look at his code. Let's look at the node, the entry class. So you see, it's an alphabetical order. We just check S. So check S is our current string, our current entry that we want to put .s less than the node we're at, because at this point we know our first node, or the node we're at. So first, if our base case here is if our pointer or if our node is empty, it has nothing. If it is empty, then you add the node. If it's not, check if the current string is less than the node string. So node. So for example, if I say A and this is B, where would this node go? So let's say this is B. This is, I'm not gonna, you know, give out the best example, but this is just an example. If the current string is A and our node string is B, what would be our, where would I put A at? Well, I will put it on the left side because, well, it's A is less than B. If let's say I have C here, I put it on the right side. So it's just simple. Just go to the left or right, depending. So you're gonna be asking yourself, how would I do this? Well, you're gonna be using insert recursion, because insert recursion has an entry of E and a node pointer. So when you're checking, hey, this string I'm at, my current string, is less than B. So just go to the left node of B. And then at that point, because of your base case, your base case is checking if you have a null pointer. And let's say, for example, B. This is B right now. And I have no left pointer. So it's going to be like, hey, I have nothing here. So just put A there. Does that make sense in this algorithm? So now that we know we inserted our tree, rebalance it. Rebalance. Because at this point, it's going to end. Once you inserted this node, you're going to go back. You're going to go back to your previous function calls. So once you hit your previous function calls, what you're going to be doing is calling a height update and a rebalance, because we added this information of A being there. And I know I'm just gonna, I'm not gonna write a whole tree, but let's see, C, and then AC, is this balanced? I think this is balanced. 1, 2, 3, yeah, this is balanced. Let's see if I do this A, no, wait, that's wrong, that's still wrong. I'm not gonna do that, alright. I'm not gonna write a lot. So always check, always update your height, because at this point, let me erase this, because this is when the function enters. And when we set a new node of A, we don't really know what our current height is. So this A goes back to the previous function call, and what you should do there is update the height. So hey, my height here is, I don't know, let's say 1. I think it's 1 or 2, because I don't know if this, no, this is 2, because you have your root there and all that, your root pointing to that one. So let me double check if I'm doing this right. Yep. And then what we want to do is check if we need to rebalance. So check for rebalance. Main reason is because when you're end sorting, I'm not gonna do your average string thing. Let's say you have this BA0. We need to rebalance this, or else this is not an AVL tree. So does anyone know what I would do here? What type of rebalancing I would use? Well, this is I believe a right rotation. Let's make sure. So I have, is this balanced? So, so this is a B. Okay, A, B, and then don't I rebalance here? Just rebalance, because it's supposed to look like this, because this off balance, and you do some rotation to the, believe, right side, because we want this as our node. So it's gonna be A, B, and then whatever this is, 0. So that's gonna be our rotation. Let me make sure I'm doing this right. So there's a single rotation. Single rotation, because I want B to be here. Oh no. Was this a right rotation? Yeah, it's a right rotation, because I want B to be here and A to be there. Is that right? Or is this a left rotation? I think this is a left rotation. Yeah. Let me. Oh, kind of. Yeah, there's a left rotation. Does Does anyone want to correct me here? Are you guys still here with me? Hello?
You're good.
Alright, so I'm correct in the left rotation, blah blah, right? Just don't want to make incorrect this. But what I'm trying to say is you should always rebalance. Because we don't want a tree looking like this. So check for your height. Check height. Or update it. And then rebalance. Two important things. You guys know the gist of insert recursion. Check your strings, because we want this in alphabetical order. If my string is less than the current node I'm at, just put it in the left node. If it's greater than, put it in the right node. Check it, recheck all of those. Alright, that makes sense. Does that make sense to everyone?
Yes.
Alright, just making sure you guys are understanding. So, the second part is size. So, for size, you have this thing called a helper function. Yes. Return the size of the root of p. Should run in O of n times int recursion node p. So, you're just going to call that function. That's mostly just it. What you're going to be... Well, I'm not going to say what you're going to be writing, but I believe you guys did this doing one of your quizzes. So, what we're going to be doing is checking our left and right. And if we have those things, then we continue on to recurse through them. We only... So, I'm going to tell you guys this is fairly simple. What we're doing is accumulating each node. So, and then I'm going to do this. So can someone tell me the height of this tree? Or this... Okay, is this the size? No, this. No. wait, I mean size of this tree. 1, 2, 3, 4, 5, 6, 7, 8. How many nodes are there? Well, there's 8 nodes here. So what you're going to be doing is you're going to be recursing through them. So you do a recursion call on this one, because we know it's not a null pointer. We know we have to check if it has 2 children. So check if it has left children or right children. And this is done by your base case. So all you have to do is call size recursion on the left or right pointer. Left and right pointer. And what would happen if you don't have anything here? For example, what would the output be? Do you have something there? Not really. So what are you going to be returning? Well, it's a null pointer. I have nothing there. So I'm just going to return 0. If I do have something there, well, let's say, for example, this one. I know I exist. So I know there's an item here. So I'm going to add +1 to my size. And I need to do the recursion calls of these 2 nodes. And I know there's nothing there. So the left is going to be 0. My right is going to be 0. So I'm just going to add 0 plus 0. But when you're doing this is another size recursion call. So you're doing a size recursion on the left and right. And since we have no children, it's going to be 0, 0. For example, if I were to do this one, I call this one, recursion call here, 1. Recursion call here, +1, +1. So this is like 3 elements here. And that's mostly just it. You just return size or whatever you're working at. Just return the number. Because at the end of the day, when you're done doing all the recursion, each time you're calling the function over and over again, you're adding, for example, let's say I found plus, you're adding you're accumulating all the nodes, all those size recursions it gives you. So for example, I have like one node here, and I did a recursion call on this node, but it doesn't have a right child, it's going to be 2. And then this one, for example, let's say I do the recursion call and it does have 2 children, so 2 plus 1, because of the other child, it's going to be 3. So do you guys kind of understand what I'm trying to say? You're just going to do recursion calls on the nodes, checking if they exist or not. And if they do exist, just plus 1, plus 1, plus 0. Plus 1, plus 0, plus 0. Does that make sense? Alright, I'm just gonna go with it. I hope it makes sense for you guys, but I believe this is also in his notes. So I'm just going off of what he's gonna be doing. So there's this fun one. I believe this is the final one. Oh wait, you guys know how to write the right rotation, left rotation, right? And rebalance, correct? Did he teach you that, guys? Did he teach you how to do that? I know he went over this in class. I just don't know if he's let's see here. So yeah, right left rotation, left right rotation, and this is just your balance. So these are the helper codes or helper so perform a right left rotation. This is the helper methods that you want. So just, just get it off the man. He's giving you a freebie. So now completion. Now let's look at our illustration of how that works. So our illustration basically says about completion. This creates a dictionary. Where does it say about completion? Coming frequently words out completer. Suggests for afternoon and after, or completions or after. The dictionary is created by implementing frequencies. Has 15. The dictionary. Okay, this is not the histogram one, is it? Alright. I'm just gonna write off whatever I have here. So, what you're gonna be working on is gonna be with, you're gonna be outputting strings. And what we want is 3 strings. So we want 3 strings of the word we just gave out, because we have the value x, which is going to be, whatever, A, and it gives me apple, epidermix, appendix, words, that sort of way, but I only want 3. Always make sure to clear your t vector, by the way, because sometimes it's going to give you errors, so clear that out. And let's get started working on the recursion. Complete recursion is what we're going to be working with. So, complete recursion takes in 3 things. Our string, which is x, the root, and let's say a vector. I believe it accepts a vector of entries. So, vector of entries. So, first things first, we should always start off with a base case, which, what don't we want? What happened if our root is empty? Always checks for that. So if P, or if our current node, I'm just going to write current node. current node is empty. Just don't do anything. Just it's an empty node. You can't get information from it. Now, let's get started into it. So, we always start off at the very top of our node. Now, let me look carefully at his thing. Because I want to make sure I'm doing this correctly. Because I feel like I'm confusing it with another homework assignment. So let's double make sure what entry has or node has. So the node only has height. Where's the string and frequency? Okay. Yeah. I mean, you can always this your height to give you. So let me see if I can understand my own code as I'm going here. So find if the string is in the correct node. How would you do that? Well, compare the current node. Compare. So compare the current node with the X string. And let's say one of the elements. So an example here would be string. And let's say if it's equal to well, technically you can't do this in C++ unless you're doing some let me erase this because it is incorrect formatting. And let's say our current X is str. Now, do you think this string is in the correct node? Well, yes, it's in the correct node. Main reason is because str. So you're going to be iterating through this string and this one, checking if their characters are matching up to the string of X. So we know we're in the correct node. If not, just you're going to do something else. If you're not in the correct node, what you're going to be doing is, so let's say for sake of right now, X T R R. So for the sake of right now, let's say string is our current node that we're working with, and X T R is the one we want. What we know is that string is a node that has two children. Now, where do you think you can find X? Well, we know that X is bigger than S. So we're going to find it in the right node. If we continue on, for example, let's say this X, A, B. So we know we found XAB. If we keep going further, we might find XTR. Now, this is the case that it's false. Let me rewrite this. So the first case is check if my strings are in the correct place. If not, check if my string needs to go to the left node or the right node. And that's only if it's false. If it's only false, just check the next nodes. Left, like how I explained. This string is bigger than this string. This goes to the right node to check if it belongs there. And let's say it keeps going on and on until it finds the correct spot. So that's only when it's false. Now, when we know we're in the correct space with let's say with string and str. At this point, we know we're in the right space. So, you have this vector of 3. Oh, this E vector. Okay. We want this item because, well, we found a match. We know we're in the correct spot. Get that string. Get it. This is yours now. This string belongs here. So, autocompleter is going to say, hey, this matches string. That looks good. The next thing is you're going to be sorting the vector. So, because, well, the instructions say here. Let's see here. Let's see. Filter the T with the top 3 most frequent completions of X. If X has less than 3 completions, then T is filled with all completions of X. Must run fast. In particular, you should not search all nodes in the tree. Instead, only search a region. K log of n, where K is the number of completions in the tree. So you're gonna sort this vector. You know, there's a fairly simple way to do this. So just compare frequencies, because you want the highest. If X has less than 3 completions, then T is filled with all completions. The completions appear in T from most to least completions. So sort it. We sort this. Well, we only have one item here, so nothing much to do. Now, at that point, we're going to be checking the next completions. So I just go for I check my left and right. And I run the function again on them. And let's say this is strangle. I don't know. I'm just making words. This is, what would I do here? This is less than, so let's say saw. And we know this one has, let's say stringle is a very popular word. This has a frequency of 1,000. This one has a frequency of 10. So what you were going to be doing in your vector is going to swap. Just swap these guys. It runs constantly because, well, we know our vector is going to only contain 3 entries with the highest frequencies, from greatest frequencies to lowest. And that's mostly it. You just sort it. Just sort it. Does that make sense? Because I explained to you guys that every single time you're recursing through it, you check if you're in the correct node. For example, that's why I said here, like, let's say saw. I'm not in the correct node, so I'm not going to give out anything. So if saw has no pointers, has no children, it just returns nothing. And for example, this one, it has its children, it has the frequency, it belongs here. I push this into my list. So right now I'll have string, and then stringly. And then let's say we have a next item, the next two items, which is like this is saw-2. How the words are. It's just an example, and let's say the next one is I don't know, sweller. Nah, this won't work because I started with string. TR Schweller. Yeah. Well, okay. Let me clear this out. So you guys get the idea of sorting. Now let's say, what was I gonna say? STR Schweller. So, and then this one has a frequency of a million. We have the stringly, and then we have string. And what you're going to be doing is you're going to keep iterating through the nodes because we want to get whatever high stakes we have. So I'm just going to do 10, this one do 1. So there's the sorted order, and let's say STR Sweller has some other child. I don't know, it has 20, 40. Then we would put it here, and then we would remove this guy. So you're keeping track of 3 items, similar to how you did Trend Tracker. Similar process of sorting algorithm. Well, it's not very... It's just a simple swapping algorithm. And does that make sense? Does anyone need me to clarify anything? So everyone is able to understand this algorithm. Did I go like vaguely? Is there any questions to be answered? I can go over some. So let me go over the thing again. So autocompleter, just create a root, insert, user insertion recursion. Size, you're going to be using insertion size. Most of these pieces of code is given to you by Dr. Scholler, but the only one that's unique is completion. So what I basically just explained to you guys is going to be it. Any questions? Any suggestions? Or did you guys fall asleep because it's like 9 p.m.?
When you said to sort the tree, are you doing it in order? Or in what order? Or does it matter?
When you're creating the tree? Or when you're... Or in the completion recursion?
In the completion.
So... In the completion recursion, you're just sorting in from highest frequency to lowest. Because you're only going to have 3 items. Because that's what it asks you. Like, you need 3 items of 3 strings with the highest frequencies. So you're going to be keeping track of these 3 items that match the string that you're working with. So if it matches, you push 1, you push 1, you push 1. Check their frequencies. Well, you're not going to push 1, check frequencies, push this one, check the frequency. Oh, this one's higher than this one. Go here, swap them, push this one. Oh, this one's higher than this one. Change that one. Oh, wait, this one's also higher than this one. Change that one. So you're basically constantly swapping. But it's mostly just like, let's say this 10, 5, and 1. I'm keeping track of my highest frequency to my least. Does that make sense? Or do you want me to explain a little bit more?
No, that makes sense.
Alright, just making sure. There's a fairly simple homework assignment, because most of it is just given to you in a silver spoon. Anyone else have any questions? It's good to know that you guys have you guys are able to understand the full complexity of this algorithm.
So the nodes are based off. So the nodes represent streams, not characters, right?
That's your next homework assignment. No, autocompleter 1. The nodes represent strings. in Autocompleter 2, you're going to be working with whatever many strings you guys have. So just a sneak peek of Autocompleter 2. So in Autocompleter 2, you're going to have nodes of characters. And you're going to be iterating through the 256 characters there are. I think there's 256. And it's going to start spelling out a word. So let's say A. And then my child here is A. So let me give you. This is not Autocompleter 1. This is Autocompleter 2. But we have 256 nodes, and then we're inserting. So we know our string is let's say is tr. We have our first string, which is t, and then this one's gonna be t, and then this is gonna be r. Well, I don't know why I'm doing it left, but it's r. And if you call this, oh, and then you have to end it. You have to end it with like I don't know, an empty node. I forgot what they're called, but it's just a node saying complete. Set it to true. This is a word, str. And at that point, you're done. You print out str, because I believe you accumulate the string when you're recursing through it, and then print that out. Does that make sense for that algorithm, Autocompleter 2? Alright, I'm gonna stop recording, and just because I don't seem to have many questions here. And hope you guys have a nice day. Hope you guys understood my example. I'm sorry if it's a little bit iffy. And see you guys next time. Okay. Alright, let me turn off the recording so I can like help you out with that one, one-on-one.